Hello, dear students. This is Irshad. Welcome to class 10 ICSE Physics. In today's class, we are going to discuss numericals on current electricity, exercise 8B, questions 21 to 26. I will help you understand the concepts and solve the numericals in a simple and easy way. So, let's start. A resistor of 6 ohm is connected in series with another resistor of 4 ohms. The potential difference of 20 volt is applied across the combination. Calculate the current in the circuit. The potential difference across B resistor is, in this question, this is the R1, R2, potential applied here 20 volt. Which type of connection? Series. Then equivalent resistance equal to R1 plus R2, 6 plus 4, 10 ohms. This is the R equivalent. Using Ohm's law, V equal to IR. V equal to IR. Potential difference given 20 volt, and the current we don't know. Equivalent resistance we found 10 ohms. Then I equal to 20 by 10. 0 0 will get cancelled. So I equal to 2 amperes. Mean 2 amperes of current flows through the circuit. This is the part A. Part B. The potential difference across the 6 ohm resistor is, so once again here, potential difference he asks across 6 ohms. I will write B1 is the potential difference across 6 ohms. Our resistance is 6 and current is into 2. Then V1 we will get 12 volt. Two resistors of resistance 2 ohms and 3 ohms are connected in parallel to a cell. Draw a current of 0.5 amperes from the cell. Draw a label diagram of the arrangement. Calculate the current in each resistor. So two resistors, R1, R2, are connected in parallel. Total current is 0.5 amperes. First arrangement of the diagram and the current of each resistor. I will draw the diagram first. First resistor, the other one. So this is the complete circuit. Above branch is a 2 ohm resistance. Below branch is a 3 ohm resistance. Current flowing here 0.5 ampere. Current flows 0.5. Then we will find first equivalent resistance between the two resistance. 1 by R equivalent equal to 1 by 2 plus 1 by 3. That is 3 plus 2 by 6. That equal to 5 by 6. Is 1 by R equivalent. R equivalent equal to 6 by 5. Divide 6 by 5. 6 divided by 5. 1.2. So resistance is 1.2 ohms. Then I will find the electromotive force of the cell using the Ohm's law. Sigma equal to current into R equivalent. Current is 0.5 given in the question. Equivalent we found 1.2. 12 5 are 60, but there is a 2 decimal points. So 0.6 volt it is. 0.6 volts. So the EMF of the cell is 0.6. So once again I will check 0.5 into 1.2, 0.6 volt, right? And now for the each branch the potential is same. The resistors are connected in parallel. Then we will write V equal to I1 R1 equal to I2 R2. So it is 0.6. I1 we don't know. Let us take R1 is 2. Then I1 equal to 0.6 by 2. I1 equal to 0.3 amperes. Similarly, 0.6 equal to I2 into 3. Then I2 equal to 0.6 by 3. I2 equal to 0.2 amperes of current. So in each branch, what is the current flows? One is 0.3, other one is 0.2. When the resistors are connected in parallel, the same voltage is applied across the resistors, and the resistance is inversely proportional to current flowing through it. More resistance, less current flows through it. Less resistance, more current flows through it. The next question. Calculate the current flowing through each of the resistors A and B in the circuit shown in the figure. Okay, there are two resistors A and B connected in parallel. Battery EMF is 2 volt. And then R equivalent 1 by R equivalent can be written as 1 by 1 plus 1 by 2, that equal to 1 plus 1 by 2, that is 2 plus 1 by 2, that equal to 3 by 2. Then R equivalent can be written as 2 by 3, 2 by 3 ohms. Using Ohm's law, the electromotive force epsilon equal to I R equivalent. Epsilon is given to I we don't know, R equivalent we found 2 by 3, and both sides 2 2 will get cancelled. Then I equal to 3 amperes. 3 amperes. Now the same potential is applied across the resistors. Then I will write it is through A, V equal to I1 R1. So V1 I will take here. I mean same potential now. So V equal to I1 is, we don't know, but we know that we don't, we know. So in place of v, I will write here 2 volt. I, we don't know. I1, R1 is 1. So I1 equal to amperes. 2 amperes of current flows through resistor A, and resistors B similarly. At B, at B, at B, V equal to I2 R2. V equal to I2 R2. Then V equal to 2. I2 we don't know. R2 is 2. 2 to 1 both sides get cancelled. I2 equal to 1 ampere. If you can go, so actually this is the point we can call junction points. P is a junction point. Similarly, Q also a junction point. At junction points, at junction point, some of the current coming towards a point equal to some of the current moving away from that point. So what we can call that junction points. So at point P, 3 amperes of current coming towards it, 3 amperes. Is 3 amperes coming towards it. It can be split into uh, 2. I mean here there is a 2 amperes current. There is a 1 ampere of current. The next one. In figure 8.52, calculate the total resistance of the circuit, the value of R, the current flowing in R. So what is given in the circuit? Uh, there is no internal resistance. From the battery, there is a 0.4 ampere of current is moving through it. There are 2 resistors here. One is 20, the other one is unknown, and there is a 4 volt of battery. I mean, like a electromotive force. First, I will find V equal to 4 volt, R equivalent equal to 1 by 20, 1 by 20 plus 1 by R is 1 by R equivalent. Na? Then R plus 20 by 20R, 1 by R equivalent. R equivalent equal to 20R by R plus 20. Using Ohm's law, V equal to IR, V given 4, current given 0.4, equivalent, we have a equation 20R by R plus 20. Then 0, this decimal point will get cancelled. 4 1 ja, 4 1 ja will get cancelled. So we have 1 equal to 2R by R plus 20. The next step, R plus 20 equal to 2R. 2R minus R equal to 20. R equal to 20 ohms. So finally we found the resistance. Let me see the total resistance of the circuit. Total resistance. Total resistance. Na? Already we have a equation like here. R equivalent. R equivalent equal to 20R by R plus 20. In place of R, write just 20. That equal to 20 into 20 by 20 plus 20. That equal to 400 by 40. 41 ja, 42 ja, 41 ja, 40 10 ja, not 2, 40 10 ja it is. 40 10 ja. Then R equivalent equal to 10 ohms. R equivalent equal to 10 ohms. The next one, the current flowing through it. The current flowing through in R. Both resistors are equal, na? 20 ohms, 20 ohms. So from each branch, the same current flows through it. So here 0.2 amperes of current flowing through this also 0.2 amperes of current. The next one, a particular resistance wire has a resistance of 3 ohms per meter. Find the total resistance of 3 lengths of this wire, each 1.5 meter long, joined in parallel. Joined in parallel it is 1.5 meter long. So 3 resistors here, 3 wires, 3 length, each are 1.5. Then first I would like to find the resistance of each one. Then R1 equal to R2 equal to R3 equal to, so resistance 3 per meter, it is for 1.5 length. Then you will get 4.5 4.5 ohms. Now arrange in parallel connection. In the question he said arrange in parallel it is. Then 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is same resistance. Now directly I will write here 3 by 4.5. That implies R equivalent equal to 4.5 by 3. Then you will get 1.5 ohms. This is the total resistance. Question B. The potential difference of the battery, which gives a current of 2 amperes in each of 1.5 meter length when connected in parallel to a battery. Assume that the resistance of the battery is negligible. I mean, in the question there is no internal resistance. And current gives, okay, what is the current given here? 1.2. Current given 2 amperes, each of length 1.5 meter length, connected in parallel to the battery. Then we will find here V equal to IR. I value we don't know. Two given to arrange parallel 1.5 it is. So V equal to 3 volt. V equal to 3 volt. V equal to 3 volt. The next one, the resistance of 5 meter length of the wire of the same material but with twice the area of cross section. Twice the area of cross section. So as we know well, the resistance of the conductor is directly proportional to length of the conductor. More length, more resistance, less length, less resistance. The resistance of the conductor is directly proportional to area of cross section of the conductor. More area, less resistance. Less area, more resistance. According to here in the question, the length of the wire is 5 meter, but the same material. The area is twice. The area is twice. Then see it is R equal to length 5 meters. The length 5 meter and resistance is 3 ohms into 3. Area twice is said. It is now ohms. That equal to 15 by 2 ohms. That equal to 7.5 ohms. In the coming class, we are going to do the remaining problems. Bye and take care of you.